Hey folks, I'm trying to stream from my phone now just to avoid any issues so that I can be on 4G also. Let's wait for everyone to join in. I think just wait here for a few minutes for everyone to join in this live session. So sorry for that. Yes, Murali. I'm on my phone. Okay, thank you. I'm just joining from my phone to avoid any issues so that even if the power goes off, I can be there on 4G. So let me just fix my phone here so that it is stable and I don't require my mic now. I'm hoping that my phone does a decent job. So just confirm if everything is all right, if you can hear me. Is there some lag? Sorry folks, sorry for the mess up. I think the power again in and the power again came back. Is everything all right, folks? Let's wait for a couple of minutes for everyone to join in. Right now I'm on my phone now. Again, I think the phone video quality is actually better than my laptop with the camera. Okay, sounds good. We'll wait for a couple of minutes. Okay, so I'm just joining in from my phone, just so that even if there is a power cut, it will directly connect from 4G. I hope so. Again, for YouTube, I think when there is a power cut, it doesn't get a stream of signal for a few minutes. It automatically assumes that the video is over and it would disconnect. Sorry for that. Okay, we'll wait for a couple of minutes. Just give it a couple of minutes. We'll wait everyone. I think the video quality is good on the phone. Yeah, I'm a OnePlus fan. So the OnePlus phone I think is doing a good job. Okay, since some of you have joined back, let's continue the discussion here. Apologies once again. I think the power that was cut earlier is back now, and because of it, my whole Wi-Fi got restarted. I'm just joining from the phone. Probably in the public live sessions, it might be just better to do it from phone. I don't know. I'm assuming your comments here also, which makes this whole viewing experience better for me. Okay, folks. So where were we? So we were discussing about the 5 rounds. Okay, here I need to be careful with my hand gestures. Can everybody hear me clearly? Is the audio clear? Is the audio clear now? Just wanted to check if the audio is clear. Okay, let me do one thing. Let me just connect on my headphones so that you might be able to hear me better. Just give me a second. Is my audio better enough? I want to check if my audio is better enough. I'm just connected on headphones. Is the audio better enough? Just want to check. Just wanted to check if my audio is better. Okay, I'm on my 4G. Just a second. Here, is there a glitch from my audio also? Let me just shut down my laptop. Is everything all right for everyone? Just a second. Let me see if there is any more glitch. Let me see if I can somehow improvise this. Can everyone hear me clearly now? Okay, so the audio is clear thanks to the headphones. Okay, so I'm assuming things are working okay for most of you, right? So let me just place my phone in this corner. Is everything all right for everyone? Sorry for that. Okay, so I'm assuming the quality is okay now. I'm just on my headphones to ensure that there is no audio problem. Okay, folks, since we are back, so let's get going. Okay, where were we? We were at the 5 rounds of interviews, right? Okay. Okay, so it seems fine to most people. So I'll just continue on this model. Okay, so where are we right now? We were at the 5 rounds of interviews, right? There is a programming interview, programming and SQL typically, which could also include some data structures and algorithms. And so then we had the problem solving round, the real world machine learning problem solving, the machine learning depth, the machine learning breadth, and the mathematical foundations, right? So you have to be careful with mathematical foundations, especially with topics like linear algebra, with topics like basic calculus, basic differentiation, which is used extensively in machine learning, and also with probability. If you can't solve a simple problem with Bayes' theorem, that's a major red flag for me. Okay, that's a major red flag. Somebody says there is some audio issue. Let me just check. Okay, is this better now? I'm on my internet connection. Okay, so video quality is not good. Why is it so? Let me just try to place this here. No audio issues. The video quality is also good. Okay. So where were we? We were at these 5 typical rounds that we have. Again, these rounds will differ a lot based on the candidate. Okay, it depends a lot on whether you're a fresher or you're experienced. And even if you're experienced, right, there are lots of variations. Even if you're experienced, whether what is your prior experience? Is your experience a software engineer experience? Is your experience a testing engineer experience? Is your experience more of a business role, like a product manager or a program manager? Or and also domains come into play. Is your experience in healthcare IT domain, or in banking IT domain, or is it in e-commerce domain again, or is it in search engine domain? Your prior domain also plays a very important role, right? So again, somebody's asking about data structures algorithms. I'll come to that. Just give me a second. I'll come to that. For freshers who may not have a lot of real world experience, it will be more simple, to be honest with you. The fresher interviews will still be very simple. Again, for freshers, if you want to crack machine learning rounds, it's very, very important that you build a portfolio of projects to showcase your skill set. Otherwise it won't work, right? So, okay, so let's go here. Let's go round by round, and what is expected from each of these experiences. Again, your experience could be various things. I've made a big list here. Software engineers or software development engineers. It could be testing. It could be QA. It could be production support. It could be database engineers or data engineers. It could be, your experience could be in big data. Your experience could be a data analyst. Your experience could be business roles like marketing, sales, product management, program management, etc. And data structures and algorithms. Your prior experience could be data science itself, right? So, and again, your background also might change. If you're a computer science student versus you're from other engineering disciplines. For example, if you're an ECE student, there is a different expectation out of you. Because ECE students, if an electronics student comes to me for an interview, I don't expect him to know a lot of advanced algorithms and data structures. Actually, I don't expect him to know even basic data structures algorithms because he has never studied them. For a fresher, his engineering or her engineering background is very important. But if you come from an electronics background, I expect you to be able to explain me Fourier transforms very well, right? I expect you to explain entropy very well because you study information theory, right? Similarly, I expect you to be very good with calculus. I expect you to be very good with vector calculus, okay? Because these are topics that an electronics engineer studies much more deeply than computer science engineer, right? And hence, I expect from a computer science student, on the other hand, I expect you to know what is a linked list, what is a hash table, what is binary search, the basic data structures. I'm not even going to some advanced graph theoretic stuff. I expect you know some basic data structures, basic algorithms. I'm not going to ask you some esoteric all pair shortest path type of problems. I'm not going to ask that. But I'm going to ask you some basic stuff. For example, this is something that many of our students are. Again, your background could be an MBA. If your background is MBA, this is also a very interesting background. I've interviewed some folks from that background. If your background is MBA, I expect you to have a lot of business acumen. If I give you a real world problem, I expect you to think much more clearly about the business than a computer science engineer or a mechanical engineer or a civil engineer, right? For example, if I give you a real world problem, I expect you to be able to come up with the business requirements. I expect you to think about what is the right metric for the business much more clearly than what a computer science engineer can think of, right? If you come from other sciences, for example, if you're a student of pharmacy, or if you're a student of biology, medicine, physics, chemistry, I expect, again, So many companies, what they do, if they have that opportunity, right, they think of these students as they try to have at least one interviewer with that background. For example, at Amazon, we interview tons of physicists, right? Because these physics guys are super strong in mathematics, and somebody who knows mathematics well, we can teach them machine learning in 1 month, right? So what we often do here is, so we used to have actual physicists who work at Amazon interview them for something about physics. If as an interviewer I don't know anything about your background, suppose you're some chemistry background person, I know nothing in chemistry. Let's assume I know nothing in chemistry. Okay, actually I'm pretty terrible in some aspects of chemistry. Then what I will simply ask you is this: okay, dude, you're an expert in some field, I'm an expert in other field. I don't know your subject. Let's find the common ground. The common ground is mathematics, right? Then what I end up doing is I end up doing more mathematics rounds, right? I end up doing one round in linear algebra because I expect even a chemistry person to know foundational maths well, because without mathematics, no machine learning, right? So again, if somebody is from statistics background, again, we had tons of stats PhDs and stats postdocs in my team. Stats guys, I'll tell you a personal experience, right? We were interviewing a stats postdoc from one of the world's best universities for my team. This person said, whatever problem we gave him, he didn't know machine learning. He was very clear. He said, I don't know machine learning. I'm just starting to learn. We said, that's okay. But any real world problem we give, he would pose it as a statistics problem and come up with a very ingenious solution. We said, wow, this guy is really smart. And when we actually did a deep statistics round, he literally nailed it. He was superb with that, right? So what happened was, we realized that this guy's foundational, again, we did some mathematics rounds for him. We realized that this person is very strong. He may not know machine learning. And when we asked him to code, he said, it's been 7 years that I coded because I worked in proving things in statistics. We said, can you even write pseudocode? He said, I can write some pseudocode. I've learned it in my BTech. It's been years that I learned, in my BStat. He was a BStat, MStat, PhD stat, postdoc stat. So he said, I've forgotten some of these, but that's okay. I said, can you write some simple pseudocode? He said, I can. We said, theek hai yaar, let's hire this guy. And he's one of the top performers in my team. He picked up all of programming. He picked up Spark. He picked up Hadoop. You name it. And he became a mentor for me later on because he taught me a lot of concepts in statistics that I was not aware of. This guy is, after all, a PhD and a postdoc stats from some of the world's best universities. So I ended up learning a lot of stats with this person on my team. So again, these are some of my personal experiences. Again, let's go round by round and based on experience, based on candidate, right? So let's take programming first. Programming round, the easiest way to estimate how the programming round would be is this. Suppose if you're interviewing at, let's say, TCS Infosys type of companies. What is a typical software engineer interview at TCS Infosys? That is the level that you can expect. At least that level or slightly lower than that level is the type of questions that you can expect if you're attending an interview at TCS Infosys type of companies. Okay, so let's broadly break down companies into again, there are some services companies and product-based companies. Within services companies, there are two types of companies again. There are startups in services companies. There are well-established giants. Even product-based companies, there are startups like Swiggy, all these companies, right? And within product-based companies, there are also giants like Amazons and Googles and Facebooks of the world, right? So typically for programming round, the rule of thumb is this. What you have to, suppose if you're attending an interview at Infosys or TCS type of companies, you look at what are the types of questions that a software engineer interview is asked. That is the maximum level that you will be asked for a machine learning round. Okay, so that is important, right? Number one. Number two is again, oftentimes there is a team had. Again, this also could change from team to team. I'll tell you how this changes from team to team in a little while. In my team, we said that the interview bar that we will have for a machine learning engineer, especially if he's coming from a computer science background, especially if he or she is coming from a computer science background, they should be able to clear the entry-level software engineer bar. Oftentimes, even if somebody does not clear that, somebody is slightly below that bar, he or she is doing very well in machine learning rounds, we would hire them. Because if you're interviewing at, let's say, Swiggy or Ola or some of these companies, right? So is there a lag now? I'm just curious. Somebody says there is a lag here. Let me just check. Let me just check if there is a lag. I'll just pause the video quickly and be back. Is there a lag now? Okay. So, is it fine now? I'm just trying to check. Okay. So, just let me know if there is a major lag for anyone, because I'm still on my same connection. Nothing changes for me. Okay. So what if I remove my headphones and actually join without the headphones? How does this look like now? Let's just see. How is this? I mean, without the headphones. Maybe there is some audio video lag because of the headphone Bluetooth connection. Is this better without the headphones? Okay, sounds good. So let me hold the phone itself then, just so that I'll just hold it on my hand for the rest of the discussion. Okay. So if you're doing programming or so, for example, if you're interviewing at, let's say, Swiggy, you look at what are the typical questions that are typically asked at a Swiggy interview, right? For a software engineer, that will be the maximum level that you'll be asked for a machine learning round. Typically, this is the typical, but there is a clause here. If that team that you are interviewing at does not do more of real world machine learning problem solving, but if they do more of productionization of machine learning stuff. Okay, there are wide spectrum of roles. There is a role called software engineer machine learning, whose job is to actually implement machine learning algorithms in software for better efficiency, right? So those type of roles, again, depends on the role. Those type of roles or those type of teams whose core responsibility is to implement machine learning algorithms efficiently, right? Those teams, the software engineering bar is going to be high. That's one type of team. Okay, the other type of team is they take a real world problem in the company and they solve it using software that is built by others or using open source software, right? So if that is the case, then the programming bar is also going to be lower, right? Again, I've seen some teams whose primary job is to actually build large scale machine learning systems. For that, if you're joining as a software engineer machine learning in those teams, then you have to be really good with software engineering skills also. Okay, number one. Number two is for real world problem solving, freshers, the level of, again, for example, if you're interviewing at Amazon, right, you might be asked some simple questions. Again, I still remember my Amazon interview. I think the programming round, I was interviewed by a software engineering manager. He gave me a simple problem to find the peak of a probability distribution. He said, I give you a probability distribution. How do you find the peak optimally? It's a very real world data science problem, right? And I came up with a simple solution for it. He said, that's perfectly all right. He asked me to explain the time and space complexity. I spent some time on space and time complexity. I explained him. And he asked me these questions because I came from computer science background. Okay, I did my master's and my bachelor's in computer science. So he expects me to have that intuition. That's why even in our course, right, for most machine learning algorithms and for most concepts, we have given the time and space complexity analysis because we assume that there are some students in our course who are computer science students who should be able to answer these space and time complexity questions, right? And that's very, very important, right? Number one. Number two is the concepts and data structures that we have covered as part of our course. Like, for example, we have covered the basic programming concepts like loops, recursion, basic concepts of SQL, nested queries. We have covered all these concepts as part of our course. Additionally, we have also covered some important data structures like hash tables, which are also called dictionaries in Python. And hash tables are one of the most widely used data structures in whole of computer science. And we have also actually discussed about how to use hash tables to productionize machine learning models in our course. Right? Also in some of our live sessions, we have discussed that extensively. So some of these programming related data structures are also extremely important. Right? Even if you're not a computer science student, because we have covered them in our course, it will be great if you could learn it. Or even if you're not a course participant, that's okay. Please try to learn the most important data structures, if not all. You have to know what is a basic queue. You have to know what is a hash table. These basic stuff people expect you to know. Now coming to real world problem solving, right? For the real world problem solving, if you are a more experienced candidate, there is a much more expectation out of you to solve the problems much more end-to-end and rigorously. For example, imagine you're a software engineer with 10 years experience. Okay, imagine you're a software engineer with 10 years experience, right? Then when you come to the interview, if I give you a real world problem, I'm assuming that for the last 10 years, you have been productionizing machine learning models. You've been not machine learning models, You've been writing software, which means you have a lot of experience and exposure on real world problem solving. So now when I give you a machine learning problem, I want you to translate all the skills that you learned, right? All the skills that you learned, I want you to be able to translate them and to actually shed a new light, because most likely you'll join as a very senior team member who will solve and who will help solving end-to-end problems. While if you're a fresher, I'm okay even if you give me basic solutions. I'm not, because as a fresher, you don't have a lot of exposure and experience on real world problem solving, right? So that's okay. If you're a fresher and if I tell you how do you build Swiggy's restaurant recommendation. Suppose I'm interviewing for Swiggy and I ask you, how do you build Swiggy's restaurant recommendation, right? That's perfectly okay. I'll still be okay if you give me a reasonable first cut solution. And as long as and again, for freshers, the interviews will be more textbookish, not too much real worldish. Okay, again, that doesn't mean that you have to pick a textbook and read all the proofs. That's not what I mean. It will be more, people can easily get away with giving first cut reasonable solutions as a fresher. But as an experienced person, you have to have more and more insight into problem solving. The same with machine learning breadth, depth, and math foundations. Especially if you're a fresher, people expect you to know math foundations better because you studied calculus, you studied some of these topics like linear algebra, probability, much more recently than somebody with 10 years experience, right? So if you're a fresher, you have to focus more and more on mathematical foundations because the interviewer may not have many touch points to discuss with you. Because you're a fresher, you've not worked on real world problem solving extensively, right? So that's very, very important. Equally importantly, you have to also think about your domain. If you're an experienced person, let's take some examples, right? Suppose you come from software testing background. Okay, let's assume you come from software testing background, right? I give you a problem. So one of the things that I've asked some of the people who come from software testing background is this very simple problem. We have built a model, all that is good, right? We have built a problem, all that feels good. Now the question here is, how do you test this model is working all right or not? Here, since you have software engineering experience, I expect you to know the strategies of testing and be able to apply that learnings to testing machine learning models also. Otherwise, see again, I'm trying to, as an interviewer, I try to give you an advantage. I try to always tell you or try to help you leverage your prior experiences. Similarly, if you come from production support, okay, suppose you're supporting some production work, because then as a production support engineer, you would have encountered a lot of production related issues that you've escalated to your software engineering teams. Then I ask you, given this problem, let's assume this is productionized, what sort of problems do you envision? And what type of care will you take to ensure that this is not the problem? Similarly, if you come from databases background, then I'll ask you a ton of SQL stuff. Okay, because I expect you to be good at database. If you're a database administrator or data engineer, I'll ask you a lot of things about feature engineering, data pre-processing, SQL, and all of that, right? If you come from MBA related roles like program manager or product manager, then typically, I'm not saying always, but typically I expect you, then I start working on more and more real world problems because most likely I want to leverage your existing skills as part of my team. So I'll give you a real world problem and say, okay, what should be the KPI for this? And why should that be a KPI and not something else? Okay, similarly, if you're a program manager, I'll ask you, okay, here is a whole machine learning problem. How do you now break it and how do you set timelines for this? Okay, these are some of the problems that you can expect if you're a product manager or a program manager. Okay, suppose if you come from completely non-IT backgrounds, suppose you come from marketing background, then I can start asking you problems in marketing. If you come from marketing background, one of the biggest applications of machine learning in marketing is in digital marketing. Then I start giving you a problem in marketing or in digital marketing and say, how will you tackle this? You said you have a lot of domain expertise in marketing and you've also learned machine learning. Now, how do you translate the skills that you have in marketing and how do you apply the domain knowledge that you have in marketing to machine learning problems? Okay. Again, somebody is asking about the Bachelor of Computer Applications and MCA students. BCA, MCA students are treated equal to computer science bachelor's degree students. You're very close to a BTech student. As a BCA student, probably you have not covered some of the important subjects in a BTech computer science, but the spectrum of topics that will be covered is going to be very similar. Interviewers will treat you as a computer science student because we expect you to know basics of computer science as a BCA or an MCA student. I think most companies will assume, I think most companies also assume MCA to be equivalent to BTech, if I'm not wrong. Again, I'm not sure about this. Somebody's asking about network engineer background. Oh, there's a ton of exciting stuff for network engineers. If you come from network engineering background, then I start asking questions on network engineering applications of machine learning. For example, can you predict what is the latency of this video? Okay, can you predict what could be the latency of this video? All networking related problems. There are tons of problems in networking. Or for example, if you're a I'm sorry. So if you're an electronics student, then I'll focus a lot, especially in the mathematics topics, I'll focus a lot on concepts like entropy, some differential calculus, especially the vector calculus part, because I expect you to be good at them, right? Somebody coming from SAP and business domain. Again, I'm not an expert in SAP. We expect you to have good enough understanding of databases and how business processes work. So then to people like those, right? So again, to people like those, we could ask questions like, okay, given this whole machine learning model, what is a production pipeline that you'll set up? If you come from data analyst background, again, this is because I've done tons of interviews for this, right? So if you're doing it for a data analyst round, right? So data analysts, so data scientists, again, these terms are all jumbled up. I know people who are called data scientists who just do Excel manipulations. Okay, so these titles are all messed up in the industry. They're not yet standardized. But to be frank with you, if you're a data analyst, I'm assuming that you do a lot of data analysis. For people like them, we typically end up focusing on exploratory data analysis. We'll ask you what type of analysis have you done very well, right? Or what type of work, what type of analysis can be done here. And as a data analyst, you have done a lot of SQL queries. We'll also start asking questions about SQL queries for you, right? So again, if you're a mechanical engineer, very good question. Somebody's asking here, if you're a mechanical engineer, I'll ask about mechanical engineering applications of machine learning. Like for example, I think we have a video on YouTube also, if I'm not wrong, wherein we said how machine learning and AI, especially time series analysis and deep learning, can be used for very, very importantly, how do you predict machine failure? Again, companies like General Electric, companies like Boeing use ton of machine learning. Okay, so we'll try and give you problems in mechanical engineering which are related to machine learning problems, right? And see how you actually solve these problems. Somebody's asking about ETL developer. An ETL developer will think of them as a database guy, right? Because you've actually built ETL pipelines. We expect you to be ETL developers are mostly data engineers, right? So they manipulate data. So then we'll focus a lot on exploratory data analysis, SQL, etc. Somebody is asking for a non-IIT tip. It really doesn't matter, to be honest with you. Maybe I'll tell you. This is my own personal experience of interviewing with some of the world's best universities, far better than IIT, some of them, right? This is a lesson that I learned in life. Okay, if you go to a top institute in the world, it could be Stanford, MIT, IIT, whatever you name it. When you get into the first role, it gives you an advantage, right? Because that brand value gets you an interview at top companies. But in the long run of a career, right, your expertise matters. I'll give you an example. I have seen IITians and people from Indian Institute of Science and some people even from Stanford and Wharton, right, some of the world's best universities, who are below people who came from no-name universities. I had a senior engineer in my team. He came from a university whose name I did not know of. Okay, but he has grown so fast because he took steps. Because he did not have a top brand institution, he first started off with a decent company, if not a great company, right? Then he worked there for a couple of years. He learned new things. He built his skills and then jumped to the next level company. Within 3-4 years, he's already at Amazon. And at Amazon, he had that fire in the belly. He's super hardworking guy. I'm not saying he's super smart, but he was super hardworking. He's still super hardworking. Today, he works as an architect at Microsoft, if I'm not wrong, right? He's super hardworking. He's super enthusiastic. He takes up new work. Okay, that person within 5 to 6 years after he graduated, he grew faster than people who graduated from IITs. Right? So in the long run of your career, whether you came, see, nobody will ask me today which university I studied from. People will ask me which company did you work at? What problems did you solve? Right? So in the long run, see, in the short run, right after your graduation, your university matters because companies don't have an alternative way to filter. But in the long run, if you keep learning, again, I think one of the biggest problems we have in the current education system is people stop learning after their university education, which is incorrect. What really matters is lifelong education. This is my own personal experience. This is something that I've told to hundreds of people that I've mentored. We tell people that if you stop learning, again, this is an advice that I give, I think, also in our course. If you stop learning new techniques in machine learning within 1 to 2 years, you're a dinosaur. Okay, to be honest, that's the reality here, right? So if you don't continuously learn, whether, see, you could be a software engineer. Again, I've seen some people who are stuck in some 30-year-old, 40-year-old technologies. They have not upgraded their skills. Okay, those people will be the first people to suffer because they're not upgrading to the new world. Right? The same is true with machine learning. I've seen some guys who are who have been in the machine learning, data science, data analysis world for the last 30 years. They start off their careers as statisticians, but they have not upgraded their skills to more modern technologies and techniques. Those guys are already dinosaurs now. We don't even interview them many times because they don't have the most important skill of upgrading themselves. Right? So whether you come from IIT or Stanford or a no-name college, it really doesn't matter if you're not continuously learning. If you're continuously learning and if you're continuously striving for excellence, step by step, then your university doesn't matter. Where did Satya Nadella do his BTech from? Not from an IIT. It's not even, so it says MIT. It's not Massachusetts Institute of Technology. Okay? It's your Manipal Institute of Technology that he did his BTech from. And today he's one of the most celebrated CEOs in the world. So your university should not stop you. Please understand that. Okay. So back to the discussion. I'm sorry. I got diverted a little. So there is also a team specific interview that happens. Okay. So in the team specific interviews, what happens oftentimes is this. Again, your interviews could depend a lot on the team that you're interviewing at. For example, if you're interviewing at a team that actually solves machine learning problems end to end, okay, then there could be more focus on the end-to-end pipeline, everything from data cleaning. And my team was like that at Amazon, right? So we were mostly solving problems end to end. Okay, we were mostly focused on solving problems end to end, which is we take a real world problem, solve it end to end up to productionization and maintenance of models. Okay, such teams interview also end to end. They look for, can you write code? Can you do feature engineering? Can you build models? Can you hyperparameter tune? Can you productionize models? Can you deploy models? Can you track how the model is working? Can you design KPIs? All these are things that these teams work on. This is one type of team. These are some of the best teams to work in from my own personal experience because you get to learn the whole experience. There are second type of teams. These are called pure research teams. There are some of those teams at IBM Research. Again, these are the companies that I know of. Those teams actually don't productionize things end to end. Their job is mostly to conduct fundamental foundational research, to write research papers and to apply for patents. Okay, such teams have a completely different bar. Such teams focus a lot more on theory because their expectation from you is to do foundational research. They actually typically end up hiring PhDs in machine learning or PhDs in mathematics, typically, right? Because they want to publish new research and get patents for them. That's the second type of roles. The third type of roles are, there are teams which do more data analysis than machine learning. And please don't look down on data analysis. I think data analysis is more important than building a model. Okay, I've seen some teams like that. They produce phenomenal results. Actually, a lot of MBA folks end up getting hired in those teams because what those teams want to do here is they're sitting on, let's say, a few terabytes or maybe a few petabytes of data, right? So what they'll do there is they'll take all of this data, they will try to churn all of the data and give business results, right? So that's very, very, very important. Again, so those are another type of teams. There are a fourth type of teams which primarily work on software engineering of machine learning. Again, that's a very cool thing, because there are very few software engineers who know machine learning. So there are very few software engineers who can write optimal machine learning code, right? So those teams don't focus too much on the models, on the mathematics. Those teams focus more on the software engineering aspects. They expect you to know advanced data structures. They expect you to know distributed systems, all of that. There are some teams, again, so these are all different types of teams, and some teams want a generalist, some teams want a specialist. Okay, what is a specialist? A specialist is somebody, okay, some teams might say, I cannot hire if you don't know Spark. So those teams are looking for specialists. Okay, some people will say, I only want people who know R. If you go to an interview to such a team, all you have to say is, I know Python, I can pick up R in a week. What's the big deal in this? Right? I know the foundational. Again, typically product-based companies prefer generalists than specialists, right? Because a generalist has foundational knowledge on everything and they can actually pick up new topics, right? A specialist knows the current fancy technology. Again, since some of our students have requested us on this, we have covered a lot of specialist related stuff. Like, for example, how does Spark work? How to train models on Spark? How to use APIs, right? How does the whole big data ecosystem work with machine learning? We have done a ton of live sessions in the recent past on those topics, because there are some companies which ask for specialists, right? With these special skills, like you have to know R. If you go to an interview like that, you say, I already know Python. This is my portfolio. And you can say, before you go to the interview, you learn the basics of R, write some code in R and show that, you see, this is the basics that I've learned in the last 1 week. Technologies change. Foundations don't change that often. Your foundational mathematics does not change every day. Your technologies change every year. Spark wasn't there when I was studying. Actually, Spark wasn't even popular till last 5 years back. Hadoop was at its infancy when I started working in the industry. So every day there are new tech. Deep learning was almost like, nobody heard of deep learning when I was studying. Right? So things have changed enormously, or at least only a few people heard about deep learning when I was studying, to be honest, right? Just a very few research people, right? So the most important aspect here is, when you're preparing for interviews, please make sure that you understand the team that you're interviewing for. It's very good when you set up the very first interview, ask about the expectation, right? I strongly recommend that you ask about the expectation itself. Ask them, what are you expecting out of a candidate? And that's perfectly all right. Actually, we ask, whenever we refer any of our students, we ask them, what is the expectation? What are you looking for? Okay, are you looking for somebody who has very strong software engineering skills? Or are you looking for somebody who has very good real world problem solving skills in machine learning? What are you looking at? Again, there are some teams, again, I forgot to mention this. There are some teams which in the math round or in the machine learning depth round will ask you to prove things. Okay. So how to tackle such questions? Such questions you can tackle by saying, see, again, if you have gone through our course, we have covered many of the proofs very intuitively. If you can reproduce the proof, that's great. If you can't, tell them that I don't remember the proof, but I can Google it up and explain you in 10 minutes. Okay. But again, you have to be confident, because as an interviewer, sometimes I've said, okay, please open up your laptop, please go through the Wikipedia or whatever you want, and please explain me the proof. And again, sometimes this happens. Okay. I don't like those proof-based questions, because what are they testing? They're not testing your real-world problem-solving skills. They're just testing your skills to memorize. Right? So as Socrates very well said, I think it's Socrates or Aristotle. He said, either you have to know things or you have to know where to find them. Okay. Google is there, right? We are living in the generation of Google. So I can find most things, but I have to be able to understand and interpret them very quickly. That is a super important skill. Oh, somebody asked about front-end web developer. I completely forgot to mention this role. So for a front-end web developer, we expect you to be very good with productionization of things. We expect you to know basic software engineering, basic algorithms, basic stuff we expect you to know, right? So you'll be treated mostly like a software engineer, but there might be some additional focus for you on APIs. So I might say, on productionization, how do you productionize this using APIs? Because if you're a front-end web developer, I expect you to know about APIs and how the whole client-server model works, all of that, much more than this, right? Somebody's asking about architects. If you're an architect, I expect, if you're a software engineering architect, I expect you to be able to design machine learning solutions end to end, right? Again, how to build domain knowledge. Again, that's something that, again, what I strongly recommend is don't try to go and build domain knowledge in a topic that you're not working in. Whichever topic you're working in, talk to your colleagues who are more knowledgeable than you in that domain. Try to understand the domain, and Google is your best friend. Suppose if you're working in banking IT, just Google search how machine learning and data science is used, right? How machine learning and data science is used in banking. Read up a few case studies. Talk to your colleagues who may have worked on that, right? So that's very, very important. So somebody is asking about a mainframe developer. Again, if you're a mainframe developer, we will treat you again on mainframes. What are you doing? Are you doing mostly scripting work on mainframes? Are you doing mostly DB2 work on mainframes? If you're doing DB2 work, then we'll treat you mostly as a machine learning engine, as a database guy, and expect you to know SQL and other things well. If you're mostly a scripter who writes scripts, then we'll treat you mostly like a software engineer, right? So again, somebody's asking about the titles. The titles are all around the place, guys. I've had 3-4 titles myself. I had titles like data science engineer, data scientist, machine learning scientist, applied scientist, AI scientist, you name it. All these are business titles that I had in the 10 years of career. Research engineer, but what I was doing was the same thing, right? So the titles, different companies choose different titles for hundreds of reasons to attract candidates, all sorts of things, right? So somebody's asking about civil engineering. Very good. So if you're coming from a civil engineering background, I would assume that you have very strong mathematical foundations and you can program. If you can't program, sorry, it's very, very important that you can program. Whatever, whether you come from physics background or statistics background, you have to be able to write basic programs. I'm not expecting some advanced programs from you. Some basic programs I'm asking you, right? If I give you 2 lists, how do you combine them without using any inbuilt functions? Can you write a simple for loop? Right? Can you write a simple if-else conditions? Can you write simple recursion? Right? So that's what we are looking for, and that's what we have also covered as part of the course. Now, for a civil engineer, I expect you to be fairly good with linear algebra because you guys use it more than most of us. We expect you to be fairly good with matrix algebra, also with differential calculus, especially the vector calculus, right? Because most of optimization that we use in machine learning. Most of optimization that we use in machine learning is all vector we use the partial derivatives extensively, right? So that's something that we expect you to already know fairly well to start with, right? So this is something that I strongly recommend. Again, if you can learn machine learning techniques, and since you're working as a research fellow, if you can apply some of these machine learning techniques to civil engineering problems, that will be great. Somebody with mechatronics background, it's mostly an electronics plus mechanical engineering. So whatever I said earlier about mechanical engineers and electronic engineers, same thing will work for you. So, somebody, okay. So people who are from, somebody is from bioinformatics background. Bioinformatics has tons of applications in machine learning. Please build a strong portfolio of projects. Again, somebody is asking about how to build portfolio of projects. We have discussed this multiple times in the previous live sessions, so I'll do very briefly now, right? So the best way is to pick up a problem in your domain of expertise. If you're working in banking IT, pick a problem from banking. If you're working in, let's say, insurance IT companies, pick up a problem from insurance. If you're working in healthcare, pick up a healthcare problem. And you can find tons of open data sets publicly available on sites like kaggle.com, or just Google search for it. Take up a problem. Again, we have an open case study in our course, right? I think one of our case studies, which is Amazon apparel recommendation, is publicly available even for our non-registered students. Please go check out those videos on how we solve a problem end to end. First you have to get the data from a site which is publicly available. Then ask yourself, what is a business problem I'm solving? Right? Again, try to tackle a problem from multiple perspectives. Design what is a business problem. First, understand what is a business problem or what is a real world problem we are solving. Then go ahead and design the metrics for it. Do all of the data pre-processing, exploratory data analysis, all of that. And after you do all of exploratory data analysis and everything, very importantly, start building. Don't stick to one machine learning model. Try to apply tons of machine learning models, because that way you can actually showcase your skills in all of them, right? Additionally, try to also shed some light on how to productionize these models. If you can productionize these models using APIs and things like that, that's great. I'll give you an example. One of our students recently, okay, somebody that we mentored very closely, a very, very good student. So his case study was very good. I'll tell you the case study that he did. So we have a self-driving car case study as part of our coursework, right? But that is using data that someone else collected. So this gentleman, who is I don't want to name him publicly, just for privacy. So this person actually used his car in India and put a webcam there and collected data from Indian roads. Okay, and he trained a deep learning model that can predict how much you should rotate your car driving wheel based on Indian road conditions. And he wrote a detailed blog, wrote a brilliant GitHub, put up all of his code. So just by looking at his portfolio, this just because of this one project that he has done, he has gotten tens of calls from companies. And companies, I think he recently joined as a very, very senior machine learning role. Very recently he joined in a very senior machine learning, almost like a VP role at a startup, and he's doing phenomenal work there. And the company loved him primarily because he took a real world problem, and unlike others, he actually went to the market, collected real world data, and solved the problem end to end and put up his whole solution. He wrote a very detailed I think these are two blogs that he wrote, or maybe one blog, I don't remember it. So he discussed everything in detail. He also showcased his GitHub profile in lots of domain, right? And he got tons of calls. So those are the types of projects that we want our students to do. Try and do world-class projects. Don't take shortcuts. Most importantly, please don't put the projects that we have as we have like some 15 case studies in the course, right? Please don't put them as case studies that you have done. You have not done them. Please. These are stuff that you have been taught by us. By portfolio, we want you to solve original problems that you have solved on your own with some mentorship from others. Okay, it's very, very important you do it. Okay, again, there are tons of great problems to solve, to be honest with you. Okay, solving them end to end shows a recruiter or shows a hiring manager that it takes time for you, that you're willing to put in time, you're willing to do the dirty work to solve a problem end to end, right? That's super duper important. Again, coming back to some of the interview stuff. For interviews, when you prepare for, again, I just wanted to mention this very clearly. When you're preparing for machine learning specific interviews, right? When you're preparing specifically for machine learning depth round or breadth round, it's very important that you understand various aspects of an algorithm. Okay, that's why we have been doing some interactive case studies recently on Applied AI course based on each technique. For example, I think last week we picked up logistic regression. We did a 2-hour live case study, not a case study. We did a 2-hour live interactive session on what type of interview questions you can expect from logistic regression. Again, you have to know a technique in depth across all the application. For example, if you tell me, again, I've seen some of the candidates that I've interviewed, I asked them, can you write what is the loss function that logistic regression minimizes? I tell them, think about it, write down carefully. They can't write it down. If you can't tell me what is the loss function that logistic regression minimizes, you don't have the mathematical depth, right? You don't have the mathematical rigor. That is important. I'm not asking you to remember things by heart. All I'm asking you is, if you want to derive it, go to the whiteboard and please feel free to derive it. I would love to see the derivation. Okay, so when you learn a technique, the theory is as important as practical. When I ask some people, okay, explain me about logistic, they say, oh, there is a hyperplane that separates all of that. That's a very simplistic interpretation. If you really know machine learning, you will say, okay, you'll give me multiple interpretations of this. You'll say, okay, logistic regression from a geometric perspective is just as this simple hyperplane, but from a loss minimization perspective, I can think of it as minimizing the logistic loss, and this is what the logistic loss does. And why should we minimize the logistic loss? Then we regularize it, all of that stuff. But there is also a probabilistic interpretation of the Gaussian naive based interpretation, and we can also arrive at logistic regression from probability. So if somebody gives me these 3 viewpoints, I'm much more convinced that this person actually knows what he's speaking. Versus if somebody says, okay, there is this hyperplane which separates these two, come on, dude. That's too simplistic. That's how you explain a 10-year-old kid. When you're in an interview, I wanted to showcase your skills to me, your breadth and depth of understanding. Similarly, when we ask you some of these boundary questions, right? For example, if you ask you, okay, how does logistic regression work when you have outliers? Or should you use regularization when we have outliers? Should you pre-process the data? You can only answer some of these questions if you understand the mathematics behind it. That's why in our course, we did focus quite considerably on the math as much as on the practical aspects. Because without math, you don't get the intuition. You're just remembering things by heart. Again, just like software engineers, right? You can remember the syntax of a programming language versus understanding how the programming language works internally. That's the difference, right? Again, there might be some people who have not too much experience, maybe 2 years experience, 3 years experience, right? So my suggestion to all of you is, for people with 2 to 3 years experience, just try to make the most of what you could have learned from the domain that you've worked in. Also become good at basic software skills, right? Basic software skills, nothing very fancy. And see, a 2-year guy, a 2-year experienced person is neither a fresher, not very experienced person. Okay, so I think there is some problem with audio. Let me just check. Everything works all right for me. Is there a problem with audio? Okay, so I just changed my hands. Okay. So if you're a 2-year experienced person, you're neither you're neither a fresher, not you're an experienced person. But I expect some maturity from you. We don't want to treat you just like a fresher. Okay, because you have worked in the industry for a couple of years, we expect that you've picked up a few concepts. Like for example, look at a software engineer, right? Somebody who works for 2 years, the expectation out of a software engineer who works for 2 years is different from a fresher. From somebody who has worked for 2 years. For example, if you're a Java developer, if you've worked in the industry for 2 years, I expect you to know the actual classes in Java, how JVM works, how the real-time engine, how the JRE works, much better than a fresher. A fresher may not know all of these things. I also expect you to know a little more about object-oriented programming than a fresher. A fresher knows the theory part of it. What is inheritance, all of that stuff. But it doesn't know how it is used. But since you have spent 2 years in the industry, I expect you to know some aspects of it, right? So, okay. So again, somebody's asking about aerospace industry and things like that. Aerospace industry, whatever I've mentioned for mechanical engineering, it's very similar. Of course, aerospace could have some specific problems. Again, as an aerospace engineer, I'm assuming that you're pretty good with mathematics. You're supposed to be good in mathematics and other areas of and calculus, all this linear algebra, probability, all of these things. So I'm assuming that you're pretty decent at them. So we'll focus more on that. And of course, it will be great if you could do a couple of real world problems in aerospace engineering or related fields which require machine learning, right? So that will be great. So again, somebody is asking about salary expectation. Salaries range widely, to be honest with you. Salaries range like crazy. Okay. And salaries depend a lot on your skills. Okay. So what we typically see at Applied AI course with the hundreds of students that we have placed is assuming a no-name college. Let's start there. Assuming a no-name college. The minimum packages that we have seen is like 5 lakhs. Okay. For a machine learning fresher. But typically we see in the 6 to 8 more and more. Okay. Even if you're decent with these techniques, you can expect 6 to 8 lakhs. And if you're reasonably good, we have seen some freshers with no-name college who have also gotten 12, 13 lakhs packages because they learned the concepts and they're able to crack interviews better, right? See, so much of scarcity of good machine learning engineers in the industry that people are willing to pay a premium. So money is not a problem, right? And see, we have had people, again, we have had some kind, because we have had students for the last year and a half or so. We have had some students who joined one company, who also interviewed at another company, got a much better package, right? And the company was forced to increase his pay because he was a very good employee. So if you are good, salaries are not a problem at all. Again, for experienced folks, you can comfortably, again, what we observe, again, from our own students, what we observe is typically a 40 to 50% hike in the salary for experienced folks. Okay, again, what I'm telling you are like median numbers or are more commonly found numbers. There are exceptions. I don't want to promise you exceptions here, right? There are people who have gotten 50 lakh packages. There are freshers who got 13, 14 lakh packages who are from no specific brand of college. There are people from top tier colleges who got 22, 25 lakhs, right? I don't want to take exceptions and say that is the truth. No, I don't want to mislead you in that direction. What we typically see for freshers is the 6 to 8 lakh bracket. Again, of course, you have to be decent with programming. You have to know decent machine learning to get into that 6 to 8 lakh bracket. For experienced folks, we typically see at least a 40% increase. But we have seen folks who have transitioned from testing QA roles to machine learning roles because they really learned the topics well. They got like 100%, even 200% hikes in some cases, right? So the spectrum is huge. It all depends on your skills, right? So somebody is asking about somebody who has a faculty background, teaching background. So if you're coming from a teaching background like me now, right, I would expect you to explain machine learning concepts well to me. Because as a teacher, that's a skill that I expect you to have learned. As a teacher, what is your job? Your job is to explain your students a concept very clearly and very beautifully, right? So my suggestion, if you're a teacher, if you've been teaching in some company, if you're teaching in some institution or college, right, and if you're preparing for machine learning roles, I mean, even for our own hiring at Applied AI course, we've had some teachers who approached us. We tell them, please record a 15-minute video explaining a concept of your choice. If you can explain this concept, we would love to have you. Well, right? So your clarity of explanation is something that people will look at. So poor communication skills, that's certainly a problem that we've seen some students face, to be honest with you. Because if you can build all the models, but you can't explain what you have done, okay, people will not believe you. Communication skills are so foundational today, unfortunately or fortunately. I've seen brilliant people who can't explain what they're doing, and we had to reject them. Because how can he work in a company? How can he work in a team if he can't forget about language? He can tell me his concepts in Telugu, Hindi, Tamil, I don't care. But if he can communicate what he's saying, I'm happy. Right? Communicate clearly. Any language is all right. Most companies, especially product-based companies, they're not like you have to speak very fluent English. Not required. If you can communicate your ideas clearly, verbally, if you can clearly if you can talk to your teammates and explain them what is happening, people are happy with it, right? So there is one more question that I saw which I wanted to answer. Physics background, yes, that's what I wanted to answer. So actually, I've had the opportunity to interview some terrific physicists. We even had physicists in my team. We had some professors of physics in my team. So I was very fortunate. One thing that I've observed with physics guys is that mathematics is terrific. Again, in physics, there is this whole area called statistical mechanics and quantum mechanics, right? So again, I'm not an expert in those fields, but one observation that I had is people from physics know mathematics and statistics brilliantly. So if you are coming from a physics background, I expect you to have very, very strong mathematics and statistics knowledge. Okay, far more than a computer science engineer, right? So if you are coming from physics background, you better be good at linear algebra, you better be good at probability. Actually, not just good, very good at it, right? You better be really good at calculus, the foundational topics. And you should be able to write some code. I'm not asking you to be a great software engineer, but you should be able to write some code, right? That's what I would expect. Again, I think I've mentioned about QA folks to machine learning. Again, as a QA person, if you're not writing code, please build that skill of writing code. Right, the ability to write code is mandatory in machine learning. If you can't write code, sorry. It can be any programming language because you can learn new programming languages later and later, right? But if you're working in QA and you don't have any programming experience, please build up your programming knowledge first. And then in the QA round, you will have to project, because you have not done a lot of programming, you have to showcase your skills on how you can analyze the quality of a model. So you built a model. I'm assuming that QA folks also do some amount of testing, right? So I assume that you can shed some light on how to test these models and how to avoid problems. Oh, people with Hadoop and Spark background, you guys have the best chance, to be honest with you, in a way. But again, you have your own disadvantages. If you have big data experience, because a lot of companies want to leverage big data right now, you have an advantage. But if you come as a Hadoop developer, I'll ask you Hadoop based questions thoroughly. I'll ask you the internals of Hadoop. I'll also ask you how to implement machine learning algorithms on Hadoop. So you better be prepared for it. And actually, it's actually a lot of fun to interview people with big data background. Any big data tool. It could be your MongoDB. It could be any of your NoSQL databases. It could be anything. Since I've worked on these problems extensively, given any major NoSQL database or a Hadoop or a Spark, we can start asking questions on you on how machine learning can be leveraged along with that tool. For example, if you tell me that I know Kafka, somebody was telling me earlier, Kafka and all these things, right? I'll say how can you use inverted indices to speed up machine learning algorithms in production? If you're using Kafka, right, then you have to know about the inverted indices, everything that is there as part of Kafka. Similarly, if you know Hadoop, you have to know MapReduce internally, how it actually works, right? So that is super duper important. Okay, so sounds good. Somebody is asking about a full stack developer to a machine learning engineer. I just explained it a while ago. Somebody says MSc mathematics with MTech computer science. You're treated like a computer science student, but since you have an MSc in mathematics, we would expect you to have far more knowledge in mathematics also. Somebody says, I don't know Kafka. You don't have to know Kafka. Okay. I answered that question because somebody asked that earlier, right? Again, Kafka and all these are tools. Okay. There is a huge difference between tools and foundational knowledge, right? Tools come and go. Today you have a fancy new database. Tomorrow it may not be there. Things change very fast in the tech world, right? So tools are, especially product-based companies will say tools are less important than foundational knowledge. Right? So somebody is asking about, I just came across this question. Somebody is asking, I think I just missed it. Okay. Somebody is saying about chances of going abroad in machine learning. I think, again, there are very few people at Applied AI course that we have placed who have gone abroad through us. Okay. People who are in US got placed in US, right? That's because of the whole hiccup with all the work visas and stuff like that. But thankfully, some companies in Europe and Japan have been hiring Indian students or Indian candidates much more freely now. We have some folks who got placed in Rakuten in Japan, some folks who are interviewing there right now. So depending, we have some folks who have interviewed for roles in South Korea, right? Again, there are fewer roles there, and you have to be really good to get some of those interview calls, to be honest with you. Right? So, yeah. Oh, somebody's talking about manufacturing sector. Yes, predictive maintenance is a huge deal. Actually, I think we have a video on our YouTube channel where we discussed how machine learning and deep learning can be used for predictive maintenance. Okay, that's a huge area. So somebody says PG diploma in statistical methods and analytics from ISI. I expect you to be really good with stats. And if you know statistics very well, machine learning is a cakewalk, folks. Right? So, somebody is asking, do we teach offline? Sorry, we don't teach offline right now because that way we are limited to a very small set of students while we want to serve a lot more students today, right? So our courses are only online as of now because we want to reach and we want to help as many students as we can. So, okay. So again, somebody is asking about data structures and algorithms. See, depending on the company that you're interviewing at, the importance of data structures and algorithms comes into play. Again, depending on your background. If you have studied undergraduate level computer science or BCA, MCA computer science, I expect you to know basic data structures, stack, queue, all these things. And I expect you to write basic programs. If you can't write that, that means you have not studied anything in your BTech or at your undergraduate level. But if you come from, let's say, civil engineering, I don't expect you to know what is a stack and a queue. Because you've never encountered that, right? Or I don't expect you to know what is a graph. But if you come from computer science background, and again, depending on the company and team that you're interviewing at also, that's what I mentioned earlier, right? Depends on your background, depends on the team, depends on the company that you're interviewing at, depends also on your experience. If you're an experienced software engineer, we expect you to know what is a stack and what is a queue. If you can't tell me, come on, sorry. So somebody is asking how to build portfolio projects. We've actually discussed that, I think, in a video on our YouTube channel. Just Google it. In the interest of time, I'm skipping that question, but I think we have answered it. So there is actually a video on how to do case studies or how to build portfolio projects on our YouTube channel. Just search that right after this.
right? Okay. So how much data, again, data structure knowledge, let's assume, okay, let's take a simple example, right? Assume that you are a computer science student. Okay. So if you are a computer science student, if you're interviewing at a services company, Infosys, TCS, Cognizant, etc., they typically ask very basic questions. Okay. They typically ask questions like, you have a linked list. How do you invert a doubly linked list? This is something that you have done in your BTech, right? Very basic concept. Or they ask you, how do you implement a queue using linked list? Or how do you implement a queue using a stack? How do you implement a queue not using a stack? How do you implement a queue using arrays? Or given two sorted lists, how do you find the median of them? These are very simple questions, right? These are very simple questions if you're a computer science student. If you're not a computer science student, they might ask much simpler questions. But if you go and interview at a top-notch product-based company like Amazon or Google, again, I'll tell you something about Google a little later. If you interview at top-notch companies, and if you're a computer science student, they expect you to be able to solve slightly harder problems in data structures and algorithms. For example, they'll ask you how to implement a stack using a queue. How do you implement a stack using a queue? It's not a very hard question. Okay, it's a fairly easy question if you are a computer science student, and it's one of the medium to easy questions that Amazon or Facebook or Microsoft could ask, right? So the question depends a lot on your background and the company that you're interviewing at. That's very, very important. Okay, so somebody is asking about books for machine learning. So my suggestion for books for machine learning would be, there is pattern recognition by Christopher Bishop. Very good book, very standard textbook, mathematically very rigorous. But the problem with most textbooks is they don't shed light on real world problem solving. They teach you beautiful theory, but they don't shed much light on practical real world problem solving. For deep learning, there is this book called Deep Learning by Ian Goodfellow and others. Very, very good book. They give you a lot of mathematical rigor, but sometimes most textbooks assume that you're a student who has all the required background, right? You know what linear algebraic operations are. You know all of this stuff very well. But the problem here is with these good textbooks, one of the problems that you'll encounter. Let me just charge up my phone. Just give me a second. I think I'm running a little low on battery. Just give me a second, folks. I'll just connect it to the battery. Just give me a phone. Just give me a second. I didn't expect to do the live on my phone. Okay, I've connected it, so I'm hoping we'll not have hiccups. Okay, so where was I? So most of these textbooks gives you a lot of good mathematical rigor. There is also elements of statistical learning by Tip Shirani and others. Terrific book. But they don't give you the intuition. Intuition is something that you have to build on your own, and practical experience. How do you take all of these learnings and solve real world problems? Actually, I personally learned that in the industry. When I graduated from Indian Institute of Science, I had a ton of theory knowledge. I could prove theorems left and right, but I could not solve real world problems. It's something that I learned as part of my work experience. And as part of applied AI course, we try to cover as much of it through case studies. So we take real world problem and solve end to end so that you get an idea on what's happening, right? So somebody says computer vision versus machine learning. I think there's not much of a difference, because machine learning folks can learn computer vision very quickly, and computer vision folks learn machine learning very quickly. So instead of saying computer vision or machine learning, just say machine learning with computer science expertise, right? So how to clear case study round or real world problem solving round? The best solution that I would recommend is actually to solve more and more case studies, to read how others have solved problems. That's your best shot at it, right? It's very, very, again, you can just Google up if you want to see how any company, again, most major companies have blogs, technical blogs on how they solve problems, or go to Kaggle and see how some of these winners have solved these problems. That will shed a lot of light on how real world problems are solved. Again, Kaggle has the problem that it doesn't solve real world problems end to end. It's more of a competition setup. While there are tons, suppose if you want to learn how to build a recommender system using for YouTube, just Google search for it. There are tons of blogs that you'll come across that people have written which explain this, right? So, okay. A good book I can pick for calculus necessary for machine learning. I don't know. See, the typical calculus books typically cover everything in calculus. They cover everything in differentiation.
limits, integration, differential equations, everything. So I don't know if there is a book that only covers the necessary part in. There is. I don't know if there is any book that only covers the calculus required for machine. I can't think of any book at the top of my head. Oh, by the way, there are some good orally books also that gives you hands-on. But one problem again, there are problems with orally books also. Orally books teach you about packages. They teach you, like for example, I think they have a book called Introduction to Machine Learning using Scikit-learn. It's a good book, but it doesn't go too deep into mathematics. It doesn't give you too much mathematics intuition also. That's a problem. So somebody says how to get head start in career in machine learning for a 12th class pass student. My suggestion for you, since you've just finished your 12th class, my suggestion for you is to pick up programming, especially in a programming language like Python. Become good at it. Also become good at linear algebra and calculus that you've learned in 11th and 12th class. That way you'll have a good idea. And if since this is your vacation time, just pick up. I mean, first of all, you need to have your foundations right. So pick up programming in Python. That's what I would strongly recommend. Also refresh your mathematics knowledge, and just start data structures and algorithms also. Why not? Right. So that's what I would recommend. Okay, folks. I think we've almost run out of time. Again, somebody's asking about mathematics courses from other online websites like Coursera. The problem with mathematics courses is they teach everything that is there. For example, if you take a calculus course, right, at MIT or Stanford, they teach everything that is there. Of course, if you have time, it's great to do it. So suppose if you take linear algebra course by Gilbert Strang at MIT, he's one of the best professors I know for linear algebra. He teaches brilliantly well, but to finish his whole lecture series will take you 3-4 months. And if you have time, please go ahead and do it. But if you're in a hurry to learn machine learning and learn only those topics which are necessary, then doing course by course might take a lot of time. But if you're, let's say, a BTech first year student or second year student, or somebody who just passed out of 12th, right? Then you have a lot of time. So then you should go and look at Gilbert Strang's videos on linear algebra. Or somebody is reminding me that I was about to tell something about Google. Yes. So Google has a very interesting culture. Whether you're interviewing for machine learning round or for any round, even program manager rounds or product manager rounds, Google has a programming interview. Okay. Google has a very deep programming culture, right? So I have encountered cases where people who interviewed at Google from my friends and family for machine learning rounds went through 3-4 rounds of programming, just like a proper software engineer, along with 3-4 rounds of machine learning, right? So Google is one type of company which gives a lot of importance to programming data structures, algorithms, right? So that's very, very important. So it depends on the company. So if I'm preparing for Google today, in addition to preparing all the machine learning, I'll prepare thoroughly data structures, algorithms, design principles, and distributed systems architectures, all of them, because I know they're going to ask that, right? While other companies may not ask that, right? So again, so that's why your preparation has to be very tuned to the company a lot, right? So yeah, that's all I had, and thanks for joining in. Sorry for the couple of hiccups we had with respect to the power cut, and my apologies for that. Thankfully, we were back on the mobile phone. Probably next time I should just do it on this mobile phone. The video quality is good. I'm hoping the audio is also pretty decent here. Somebody. Okay, somebody again. Before we take leave, somebody start talking about mobile app developer. Look at this. If you're a mobile app developer, one thing that I'll ask you again, if you have learned machine learning, we'll treat you mostly like a software engineer itself. But in addition to that, one very interesting question that I used to ask these folks is, how do you take a machine learning model like a random forest and implement it optimally on iOS or on Android? Okay, very important question, because look at this. Because on a smartphone, I have battery constraint, which I don't have it with desktops and laptops. So in addition to all these constraints, you also have to design algorithms that will not consume lots of battery, right? So that's very, very important, right? So okay, that's all I had. And in the interest of time, since it's a Sunday, people might want to sign off from here. And thanks a lot for joining in, folks. Thanks again. And sorry for the hiccups because of the power cut. We'll try and do more live sessions like this. in the interest of everybody, but these live sessions will be more in general, right? So any questions that I could not answer here because of time constraints, please feel free to shoot an email to us. We'll try and respond back to you as soon as possible. You can just email us at team@appliedaicodes.com and we'll try and do our best to answer as many questions as we can. Okay, folks, thanks a lot. Have a good weekend and have a good time. Bye-bye.